All right, so this learning here is going to be different than you've seen before. It involves things that you know how to do, but you just have to see them in a new way. And that is projectile motion. All right, so a lot of real world problems or actions result in a parabola, like when you kick a ball, you throw a ball, you shoot a ball, a lot of things involving balls in sports. Anyway, you shoot off a cannon or a gun or something at a certain angle, or even straight. Even when you shoot something straight, it eventually comes down and like goes to the ground, right? So it's still a parabola. Maybe you're jumping off of something, or something is falling from a height. Those are all parabolas when you see their graphs. All right, and so a lot of time there are many factors involved, like wind or your initial velocity or gravity and things like that. For our purposes, we're just going to be looking at simple situations. So we're not going to have like wind or something like that. So it's not physics problems that we're doing here, but we're just kind of ignoring some things. All right. So when we look at these problems, we have two basic situations. So you see a lot of these like weird like subscripts. So those right there just means velocity at time zero. So you say that v sub 0, or you just say v0. So that just means your initial velocity. And S0. S is your position. S is like when you're doing physics or like in math, like S is a variable for your position. So this is your initial position. So it's where you start from. And over here again, initial position. Now, your paper has a little T right here. You need to scribble that off. All right, it's not supposed to have a T there. I made a typo. All right, so let's write down what these things mean. So when somebody says h of t, that is your height at time t, right? And remember t, we might as well do that now. T is time. When somebody says v0, that's your initial velocity. So that's like, when you're throwing the ball, how fast you throw it. If you're actually jumping off the cliff, like how fast are you jumping? How fast is the cannon being shot? So that's your initial velocity. And S sub 0 is your initial position. So your initial position is like this guy. He's kicking the ball from the ground, so that would be 0. But the initial position of the ball here may be like 6 feet high because a person's 6 feet tall. This guy, however tall he is, maybe the ball is at 7 feet when he releases it. How high is the ball, or how high is the cannon? Okay, and gravity. So you got to know a little bit about gravity. You're going to see this here. This negative 16 is gravity. So gravity, the force of gravity, like in our world, is negative 16 feet per second squared, or feet per second. Oh, feet per second squared. Yeah. Hang on a second. Let me look that up. I think it's per second. Oh, no, it's just per second. Yeah, not squared. Sorry. All right. Anyway, so you'll see that number in the problems in some places. And if people choose to do it not in feet per second, but in meters per second, then you'll see this number quite a bit also in meters per second, a different unit. It's negative 9.8 meters per second. So that's just, meters instead of feet. Okay, so you'll see those numbers like in physics a lot. Like you'll see them in your problems later when you take physics. All right, so let's take a look at some of the important pieces here. So we're going to have to be able to find these things on a picture. All right, so our height at time 0. So our height at time 0 is right here. It's going to be our y-intercept. Because that's when the time is starting, and we're starting from there, and so that's our height at time 0. Right, so basically, we're going to plug in 0 for the t value. So we're going to get 0 something, right? Right. At what time was the maximum height reached? So that's going to be where our maximum height is, and I want to know what time this came from, right? What time did it happen? So that's going to be our x value, or our t value in this case. So it's going to be the x value, or the t value, you can say, of the vertex. And we're going to find that by using the formula for the x value of the vertex, negative b over 2a. Notice that's the beginning of the quadratic formula, right? Your quadratic formula is negative b plus or minus all this stuff over 2a, b squared minus 4ac. So you can remember it because you already recognize it from there. Okay, so negative b over 2a, when you have a quadratic equation, will give you the x value of the vertex. Okay, and what is the maximum height? So if you know the x value, you want to know when how high the thing was. Well, we are just going to plug in negative b over 2a into our equation. Right? So when I find this number, I'm going to plug it in to the original formula. All right, and then what time did you land? So look over here when this thing lands right there. That right there is an x-intercept. And so to find an x-intercept, you could do one of two things, or many things. You could solve by square roots, you could do the quadratic formula, you could factor, but a lot of these problems are going to have decimals and they're not going to be able to be factored really easily or at all. And so we're going to be safe and we're going to just use our quadratic formula. Okay. All right, so here we go. Let's try one. All right, so a ball is thrown upwards from a height of 15 feet, so that's important, with an initial velocity of 5 feet per second, and use this formula, make an equation for the path of the ball. So look, so 15 feet, that's pretty high. I guess I should have made that a little bit lower, but we're going to go with it. So this is 0, 15, that's where we're starting. And the ball, like maybe somebody's standing on a chair or something, or maybe a really tall person, whatever. So the ball is going to fly up in there and land, right? And there's a little guy throwing a ball. So our equation, that initial, I'm sorry. Oh yeah, okay. So 15 feet in the air, that's my initial position. And 5 feet per second, that's my speed. That's my initial speed right there. So my equation is this, h of t, negative 16 t squared. This is going to be 5, so plus 5t, and then plus 15. So there's my equation. So most of the time I'll just give you the equation, but I was just trying to get you to see where those things go. All right, so after how many seconds does it reach its highest point? So I want to know, what is this value? What's the t value? This is my time, and this is my height, h of t. All right, what is the time when this happens? Well, that comes from doing negative b over 2a. That is going to be the x value or the t value of this high point. All right, so let's look at our problem. B is right there, so negative 5 over 2 times a is negative 16. So it's going to give me negative 5 over negative 32. So I'll just grab my calculator. Let's see, negative 5 divided by negative 32. So it's going to be 0.1, we'll just say 0.16, so 0.16. And it's a word problem, so I got to answer. How many seconds? Oh, 0.16 seconds. So it reaches its high point pretty quickly. All right, what's the highest the ball reaches? So I want to know the y value for this x value I just found. So I want to plug this into my problem. So negative 16, 0.16 squared, plus 5 times 0.16 plus 15. So use Desmos if you're at home and don't have your calculator, but I just want to plug this in. So negative 16.16 squared plus 5.16, oops, plus 15. Okay, so 15.39. So 15.39, and that's going to be its height at that time. So we're in feet. Okay. And after how many seconds does the ball hit the ground? So I'm interested in the x-intercept. So to find an x-intercept of this problem right here, I definitely don't want to try factoring it or anything else. I'm just going to use my quadratic formula. So for my quadratic formula, I'm going to need my discriminant. I'm going to find that first. So 5 squared minus 4 times a is negative 16, and c is 15. So I find that discriminant. So 5 squared minus 4 times negative 16 times 15. Okay, 985. All right, so I'm going to go ahead and put that in my quadratic formula. So my quadratic formula says that it's this number, negative, so negative 5 plus or minus the square root of this one over 2 times a. Well, 2 times negative 16, I can do that, and that's negative 32. All right, so I'm going to get 2 answers from this, and this is going to produce the time at which it hits the ground. That's going to produce 2 answers. So it's going to produce the answer back here, which I'm not interested in. It's also going to produce the answer over here. So let's see. So let's put that in our calculator. I need a fraction. I need negative 5 plus the square root of 985 all over negative 32. So this is obviously the number that's back here. So negative 0.82 seconds. But then the other one, so I want to go up and grab this because I don't want to type it again, and I'll just go and change the plus to a minus. So 1.14. So that's the one I want. At 1.14 seconds, it hits the ground. And that's just the gist of everything that we're going to do. It might be a different situation, but that's basically it. All right, so on your paper, I decided to change this after I already had it printed off. So go ahead and take a moment and pause. And I just, instead of the pigs jumping off a cliff, they're just falling off the cliff. And this is just a new equation. So just take a moment, pause, and change that. All right, so let's draw a little picture here. So if I plug 0 into this problem, the answer is 25. So my intercept is 0, 25. So these pigs, they're just jumping off here. So this is the highest spot, and they're just basically falling off. And so actually they're not jumping, they're falling. Because if they were jumping, they might go out first and then down. They're just walking off and going, pew, all right? Stupid pigs. All right, so this is their equation. So actually that's my high point of my graph, but you'll see in a second. How high was the cliff that these were falling off? So at time 0, it was 25. So 0, 25. Plug in 0, get 25. So I'm going to say 25 feet. Poor pigs, I hope they can swim. All right, at what time did the pigs reach their maximum height? So remember, that is my negative b over 2a. Well, what's the b value here? It's 0. So I'm going to get negative 0, so 0 over 2 times negative 16. Well, that's just going to be 0. So it's 0 seconds. That's when the pigs were at their highest, because after that, they were just falling down to the water. All right, what was the maximum height? Well, I got to plug 0 into this problem. So negative 16, 0 squared, plus 25. Well, we already knew that 25 was the highest because they didn't get higher after they fell off the cliff. They went down. So that one equals 25 feet, right? Yeah, feet. All right. How much time did the pig spend in the air before hitting the water? So I want to know what time they hit the ground. I want to know this x-intercept right here. So I got to do my quadratic formula. So we're going to do negative b. So b is 0. So 0 plus or minus the square root. Let's figure out our discriminant over 2 times negative 16. So negative 32. So let's figure out my discriminant is b squared. So that would be 0 squared minus 4. A is negative 16 and c is 25. All right. So I got 0 minus 4 times negative 16 times 25. So 1,600. Okay, so here we go. The square root of 1,600 is actually 400, but we'll just put it here. So you need a fraction. I don't really need I can put the 0 if you want. 0 plus the square root of 1,600 over negative 32. So that's obviously giving this answer in the back. So negative 5/4. Well, 5/4, if I change it into a decimal, negative 1.25 seconds. So I can't go back in time, so I don't want this answer back here. I want the other answer. So basically I'm going to go up and grab that again and just change my addition to a subtraction. So all that's going to do, because I have a 0 here, it's just going to make my answer positive. So it's positive 5/4 or positive 1.25. So that's the one I want. So 1.25 seconds they spend in the air before they hit the water. All right, we got one more. Okay, so This kid is like shooting off a toy rocket, launched vertically upward from ground level. So ground level, that means his initial position is 0. The initial velocity of 50, so that's going to be here. All right, so here we go. So here's my equation. H of t is negative 9.8. There's that gravity number in meters per second, right? This is meters per second. T squared plus 50t, and then plus 0 because it's off the ground. So that means it's starting here, shooting off, and then coming back down. Okay, so this initial is 0, 0. Okay. All right, after how many seconds does a rocket reach its highest point? So I want to know this number that gives me this number. So that's my negative b over 2a. That is the x value of the vertex. So the b is 50, so negative 50 over 2 times negative 9.8. All right, so let's see. 2 times negative 9.8 is negative 19.6. So I got negative 50 over negative 19.6. So 50 divided by 19.6, because they're both negative, so 2.55. So that's how long after the rocket leaves, after shooting off, that the rocket reaches its high point up there. So 2.55 seconds. All right, what's the highest height? So what height does it do at 2.55 seconds? So I want to plug 2.55 into here. Plus 50, and then 2.55. Okay. All right, so let's see. Negative 9.8, 2.55 squared, plus 50, and then 2.55. All right, 63.78. And that would be meters. Meters. You have to put units or points off. All right, after how many seconds does a rocket hit the ground? So I'm interested in the x-intercept. So I want to do my quadratic formula. So my quadratic formula is going to be negative b, so negative 50 plus or minus a square root. I'll get my discriminant in a second. Over 2 times negative 9.8. So we already did that earlier. That was negative 19.6. So let's figure out my discriminant. It's b squared minus 4 times a. Well, a is negative 9.8. And c is 0. So this is all gone. My discriminant is just 50 squared. So 50 squared is 2,500. So 2,500. All right, let's get our two answers. Now, pretty much what's going to happen when I do the addition, it's going to get me the answer back here. When I do the subtraction, it'll get me the answer over here. So I really just want the subtraction answer, but we'll just do it just to see. And actually, I know the addition answer better be 0. So let's see. All right, so I get negative 50 plus the square root of 2,500, which is 50. Come back here. All right, over negative 19.6. So this better be 0. Yay. All right, and then go back up and grab it, or you can press second enter and it retypes it for you. All right, and I change that to a minus. So 5.1. So 5.1. So that would be 5.1 seconds. Not much fun. 5 seconds in the air. All right, that's it. So basically you have 4 problems to do. And those 4 problems, you're gonna draw a picture. I gave you the equation and some information, or sometimes I just gave you the equation, okay? And you gotta find these things and draw the picture. All right, and here also, here's equation stuff, okay? And so that's basically it. You need a calculator or Desmos to come up with your final answers. Remember, units. Either put meters or feet, and put seconds as your time. Okay? All right, I'll see you in class. Bye-bye.